Test, test. Good afternoon into evening, everyone. Welcome to our Silicon Valley Clean Energy Authority Board of Directors meeting for May. We'll call this meeting to order at 5:06 p.m. And we're a little earlier than usual as we have a special meeting, special workshop and presenter to start off our evening. But first of all, I'd like to go through roll call, please.
Sure. Vice Chair Abikoga.
Here.
Director Craig.
Here.
Alternate Director Schmidt.
Here.
Director Sinks.
Here.
Director Miller.
Here.
Director Rennie.
Here.
Director Tate.
Here.
Director Grilly.
Here.
Director Smith.
Here.
And there are no other directors or alternates that I see present.
Great. Thank you. And then we'll next go into public comment on matters not listed on the agenda. The public may provide comments on any item not on the agenda. Speakers are limited to 3 minutes each. Do we have any members of the public wishing to address the board? No? If not, then we will go to our regular calendar, which is our special speaker. This is kicking off I guess that it'll be an ongoing series of workshops and presentations to do a deeper dive on some of the issues at hand for our organization. And so this evening, we are pleased to have David Caneda, who's a principal and thought leader with the Integral Group. And he has, I'm going to say, many decades, apparently, more than 20 years, as his bio says online, but many decades of extensive experience in the building services industry in North America and Europe. And as managing director, his responsibilities include strategic planning, sustainability, research, peer review, conceptual design, and interdisciplinary coordination. He shares his in-depth knowledge with various public and private advisory boards and has contributed to programs for the U.S. Department of Energy and the CEC's Public Interest Energy Research Program. He's played a vital role in several award-winning lighting design projects and has been recognized by the National Register of Peer Professionals. And like us, he's often been sought after as a presenter and has delivered various presentations on sustainable electrical design at conferences and universities throughout North America. And so we are pleased to have you, David. Thank you. Welcome and thank you. And take it away. Yes.
Thank you. I'm honored to be asked to present to this board because I've been following Silicon Valley Clean Energy since before it was actually established, and I think what you guys are doing is great. So Don Bray, who's over there, asked me to come and talk to you a little bit about some of the work that we've done on net zero energy and a little bit of kind of like what's the state of the art and kind of what are some of the things that we're doing now and that we're thinking about for the future. And I'm really lucky my partner, John Andre, freed up. He's a really busy guy. And I'm an electrical engineer, so I know kind of about the electrical systems on buildings, but John's a mechanical engineer, so he knows about kind of the air conditioning and some of these other systems that use energy in buildings. So between the two of us, we'll work together to develop designs for buildings. So the first thing that I wanted to talk about a little bit is just, net zero energy is something everybody's talking about right now, and a lot of people are saying, oh, it's really hard to do, it's really expensive, you can't really do it right now. So the first thing I wanted to do was just fly through some projects that just 90% of these I've been involved with or John's been involved with. So it's just a very small sample of what's been done, but it'll give you an idea that there's a lot of zero energy work that's been done, and it's been done in our neighborhood. So this is a little bit about Integral Group, our company. We've got offices throughout the US, Canada, and in the UK, and we now have an office in Sydney. And we've done a lot of zero energy work. So this is a list of projects that are either designed or in design or completed. And I just thought I'd start out with a little bit of a timeline just to kind of give you a sense of what's happened and how quickly it's happened. And so, 1978 was when Title 24 was first announced, right? So that's not so long ago. 1993 is when the USGBC was created, but they didn't actually start the rating system till around 2000. 2007, I worked on a project, and that became the first net zero energy commercial office in the United States. So it's not that long ago. And that's in San Jose. 2008, California announced their zero energy goals for the state. That was Arnold Schwarzenegger. And then, is somebody here from Los Altos? There you go. So 2013, the very famous Packard Foundation was completed. And is somebody here from Sunnyvale? There you go. So, and in 2015, in its own way, the equally famous 435 Indio, which, do you know about that project? Oh, there you go. Not so famous. So this one was really under the radar, but in some ways, I think it's more important than Packard Foundation was done. And John and I I can tell you why. I'll get into that later, but it's pretty interesting. 2020, I think you all know that the goals are for new residential construction to be 100% zero energy, and 2030 for commercial buildings to be zero energy. So like I said, very, very quickly, I want to just shoot through a bunch of projects that are zero energy, just to give you some idea of kind of what types of projects people have been doing. So residential, this is actually Cupertino. Who's Cooper? Oh, there's Rod. Yeah, so Cupertino's got this. Shh.
That's your house. I've been there. And thank you for living in Cupertino.
And there's another Cupertino project later on, by the way. So single-family residences. This is Southern California, multifamily. This is actually low-income housing, believe it or not.
Wow.
Right? So, it's doable. This is actually up in Washington, so they beat us on like multifamily, and you know how cloudy it is there. This is it, believe it or not. So this is educational, Vancouver, Canada. This is anybody from Liz isn't here. So this is in Campbell, the high school science building in Campbell. Oakland, all educational, East San Jose. San Jose. Hey, San Jose's ahead of us.
Got anything from Los Gatos?
Do we have anything in Los Gatos? No, huh? No, but we'll be willing to design one for you. Oakland, Unified School District. Hawaii. This is up in Sonoma Academy. So a bunch of educational projects are zero energy. A lot's already been done. University, or I'm sorry, this is college. Stanford. Commercial offices, believe it or not, this one's not even in California, which is got good sun access. This is in Boulder, Colorado, which is much colder. This is one of John's projects. Packard Foundation, of course. This is in Palo Alto on Page Mill Road. This is another one of John's projects. This is in the NREL facility in Golden, right? Golden, Colorado. So still the biggest? We think it's the biggest office building in the world that's net zero energy. This is our little first attempt at zero energy in San Jose that I was talking about earlier. Cliff Bar's headquarters in Emeryville. This is the Indio project that I was talking about in Sunnyvale. And then next door to it is another project on Matilda and Indio.
Oh, yay,
Who's from Mountain View?
Finally.
Okay, there you go.
I knew we were in there.
AP plus I, right? Their headquarters on Easy Street. I was just here. I just put this photograph in right before I came here because I just took this about an hour and a half ago. This is Pastoria, also in Sunnyvale. So Sunnyvale is like way ahead of all of us. We need to do something about that. This is the LinkedIn building in Sunnyvale.
That Pastoria one.
Pastoria is right around.
Yeah,
like
no,
a
I
block.
know. I mean, I saw the sign. They have a
Oh,
sign
yeah,
out
yeah, it says
front
net zero
that
energy. I
says
took a
net
picture of
zero
that too.
building right now, or
Yeah. Actually, you said that. Can we say who's leasing it? Okay. Sorry, I can't say who's leasing. We think somebody's leasing it, but I don't know if it's been announced yet. So, DPR's construction's office in San Francisco, and they've done a bunch of zero energy. All their offices are one by one. They're making them zero energy. So there's like one in LA and one in Arizona, and I think one in Washington D.C. This is Xilinx's campus, one of the buildings. It's a remodel. So actually, the other thing is about a third of these buildings are remodels. They're not all brand new construction. So it's not like you can only do this with new construction. You could, a lot of these are kind of old buildings that have been repurposed. This is a botanical gardens up in Vancouver. Oh, there you go, Rod. This is Cupertino. McClellan Ranch. This is an exhibit at an aquatic center down in, not an aquatic center, aquarium down in Long Beach. The Yosemite Institute. The Exploratorium up in San Francisco, most of you probably know that. This is another one of John's projects. This is the SMUD East Campus, I think it's called. Huge, it's the whole campus is net zero energy, not just that office building. So they have kind of like maintenance facilities and things like that. Watsonville. San Jose's Innovation Center. The water utility company in Denver. Half Moon Bay Library, Elk Grove Aquatic Center up in Sacramento. Atherton's new Civic Center is going to be net zero energy. Hayward's building a library that's net zero energy. This one's really interesting. This is Santa Clara's aquatic center that they're going to redo, and we're actually talking to them about trying to do it as a microgrid so they could take that net zero energy, connect it to a battery, and if there's an earthquake or something like that, they have water on the site so they can, they have solar hot water so they can heat water, put up people, flush toilets, give them showers, and have electricity, recharge phones and things like that. So this is an area where a city could really take a leadership role and do something beyond, you know, just putting up another building. Remodel, state lottery offices. You know, a DNA research lab, believe it or not, which is very energy intensive, down in San Diego for Craig Venter. This is another of John's projects. This is a medical office building, net zero energy. And in this case, he managed to do it, how much, $1 million? He saved $1 million off of Kaiser Permanente's budget for just a regular office building, and it's going to be net zero, right? So that tells you something that, you know, everybody thinks, you can't afford to do this, it's too expensive. There's ways of doing it. This is in San Leandro, a training center for electricians. And this one just got, is Milpitas? Milpitas is now part of the group, right?
almost.
So Milpitas, as far as we know, has the first net zero energy manufacturing facility in the country.
Wow.
Right? I've never heard of that being done before. Are you aware of that one?
No.
oh, you guys are killing me.
We are now.
So anyway, so a lot of work, hundreds of buildings now have there's now a group that's tracking zero energy projects on you can see the growth year on year. And so the one I wanted to talk about was this Indio project in Sunnyvale, just to give you a couple of interesting facts about it. So the developer actually spoke last week at the What's for Lunch meeting that you guys hosted. It's a long story that I won't get into, but this guy's a for-profit developer. He's not doing this just to save the world. I mean, he's a good guy and all, but he wanted to make money while he's doing it. And so we went through this long process to kind of figure out how to do this cost effectively. And he thought he could do it, and he built it and tried it out. And this is his numbers based on the actual costs that he incurred. So that was what he was expecting to spend if he did a renovation on this existing building to do the renovation. That's what he actually spent. So he gave us, what was it, $48.73, I think, something like that, or a square foot extra to do this project. And he said, if you could do that, we should be able to make it pencil. Then when he did his calculations, he figured out that he made $2 million more than he would have made otherwise. And that's after you put in those additional costs. He had an additional $2 million on top of that. So it cost him an extra $1.5 million, but he paid off that $1.5 million extra, and he made $2 million in addition, according to his calculations, using a 7.5% cap rate, which that's not engineering stuff, that's finance stuff. So evidently that's a reasonably conservative cap rate for this neighborhood. I don't know if any of you are developers. You could talk to that. The other way he looked at it was if he didn't sell off the building and he kept leasing it, he said about a 5.9 year payback for him. And so I always joke that if it was me and I did the project and it didn't quite pencil out, I might maybe lie about it or bend the truth slightly about it and say, oh yeah, it worked. But I know he made money at it because he's now done 4 buildings, one a year for the last 4 years, and he did that manufacturing facility in Milpitas too. So he's been kind of cranking out these projects, and he's a for-profit developer. He wouldn't be doing that if he wasn't making money doing it. So he's kind of figured out a way to do these things cost effectively. So I guess my message is that lots of people are doing zero energy buildings, lots of different building types, and some of them were, amazing but honestly quite expensive. The Packard Foundation was very expensive, but I think it was projects like the Packard Foundation that helped us get the knowledge to be able to figure out how to do it in a cost-effective way, because they gave us a big budget and said, just get us there, figure out the most effective ways to do it. And it's super energy efficient, that project. It got all kinds of national awards for innovative design and things like that. Okay, so very quickly, I want to just talk you through kind of how do engineers like John and I think about designing zero energy buildings. It's actually quite simple. So the first thing is everybody's like, can you even go to zero energy? There's a lot of things that need gas or, around here people don't typically do all electric buildings. In some other parts of the country, it's not that uncommon. And the two things that came out, actually, an architect friend of mine just did a survey and sent it out to the state AIA. And he talked to a bunch of experts about, can you do all electric buildings yet? And the two things that came up were cooking and domestic hot water heating. And in actual fact, I think, is the code, as far as I know, the code still says that you have to do natural gas, high efficiency boilers with natural gas, I believe. I know when I did my home, I had to write a letter to the head of the building department saying, I want to break the law. I want to put in an air source heat pump for sorry, Rod. I want to break the law. I want to put in an air source heat pump to make hot water rather than a gas-fired boiler. It's more efficient and better for the environment. I'm going to offset the energy use with photovoltaics. And fortunately, the guy was an old solar hot water guy, and he said, just write the letter and I'll sign it off. That's great. And he let me do it. But at the time, it was technically illegal that you were required to put in gas-fired high-efficiency boilers. So there's now quite a few manufacturers of heat pumps that will take 1 unit of electricity and make like 3 or 4 units of heat, depending on the outside air temperature. And they're very efficient ways to make hot water. They'll work down to like minus 10 or something like that Fahrenheit. So in this neighborhood, it's not a problem. Maybe if you go up to Tahoe, you could run into issues. So that problem's solved. The architect that wrote that memo that I was talking about was in the process of buying one of these to stick it in his house. Then the other thing that keeps coming up is cooking. And so I've got a lot of stories about that, but does anybody have induction stoves in? Okay, so you know, I don't even have to tell you about it. But, so the interesting story is we're working on the Cliff Bar headquarters that I showed you, and at one point they're looking at putting a restaurant, a professional restaurant, not their restaurant, but have a restaurateur come in and run a restaurant in their facility. And so they found this guy that they wanted to do it, and he said no. And they said they wanted him to use an induction stove in his kitchen rather than gas. And the restaurateur said no. And so they kind of talked to him, and finally he said, I will try an induction stove. If I can cook scallops on it, then they cook up properly, I'll sign off on it, but I'm not going to be able to. So there's this like commercial kitchen place up in San Ramon that he went to, tried it out, and signed it off, right? And so I actually have induction in my home. We have this brand of, I don't know if you recognize what that is, but that's a induction wok burner. So it's like specially made so that wok fits exactly into that dimple. So when we built our house, I did a search under induction wok cookers, and 2 manufacturers came up. So I asked my wife to go try it out. She went to the first one, Gaggenau, called me up at lunchtime, said it's crap. I'm not having it in my house, forget it. And I'm like, oh, jeez. So I was like, okay, let's check the other one out just in case, maybe it'll be better. So that weekend we went to the other one, which is this one, which is Cooper's Bush. The guy kind of gave the demonstration, put water in it, started boiling within 10 seconds or something. And invited her to come back on Monday with some vegetables and try it out. So she decided to do it. But the thing that he then said that was the clincher was, as we were walking out, he said, a lot of these Chinese, my wife's Chinese, a lot of these Chinese families really like this, because what people do is they get an old towel and put it over the burner and put the wok on top of it. And then when they're done cooking, they just take the towel and throw it in the wash because it catches all the spatter. And as we were walking out, she goes, if this works, we're getting it. And it worked. So, and they're really fast. My kids complain about using a gas-fired boiler because they say my sister, Aunt Kathy's gas stove is like so slow, it's like really irritating. So how do you design these systems? First thing is collaboration with the engineering team. So energy suddenly becomes an important piece of designing these buildings. And so a lot of architects like to design the building and then kind of throw it at us engineers and say, here, stick your stuff in it. And that doesn't work well because architects don't necessarily understand kind of what makes a building energy efficient or not energy efficient. So there's got to be that collaboration. The most important piece is kind of early on the design. This is kind of from beginning to end of the project. So in conceptual design and schematic design, when you're trying to figure out what the building shape's going to be, the very basic stuff, then we need to be talking to the engineers. It's really important to pick a kind of energy target, how much energy that you're going to try to have the building use early on. That's pretty aggressive because that becomes the discipline that you use to make sure that you're not using that you're kind of going to be as efficient as you want to be. If you don't do that, then it's really easy for things to get out of control and suddenly the building's not efficient. So kind of this is a typical project that we would do where we set a pretty aggressive target, and then as we start looking at systems, our team will do really quick, they call them shoebox models, so we'll look at a shape of a building or an amount of glass or levels of insulation and quickly model it to look at how much energy does it use and figure out which ones use less energy, and then we could also look at which ones use less energy and aren't too expensive, right, and to try to marry those two together. And as we're doing it, then we're constantly going back and looking at costs because otherwise you end up doing something that's fabulous but costs a fortune and you can't afford to do it. And there's just 5 areas that you need to look at. It's pretty simple. So the first one is the skin of the building. So that's kind of the windows and the walls, basically, in the roof. And kind of how much insulation, what color, what materials, how much glass, things like that. So this is just a typical building that we were looking at that our daylighting person was looking at, how much light, and then our energy models are looking at what's the impact on the air conditioning and heating systems. Daylighting is a huge thing, so being able to use daylight in your building to reduce your need for electric light is a big issue. Even though nowadays electric light's gotten much more efficient. So, using LEDs is important. Dimming those LEDs if you have daylight in the space is really important. But we've done projects where, compared to the average US office building, we've had the lighting budget come in at maybe 8% of what a normal building uses, believe it or not. So, especially in an office building, it's only used, well, not only used, but primarily used during the day. So if you have good daylighting, you can just have the lights off all day long, and you're using practically nothing. Air conditioning systems, and John can talk to this more if you have questions about it, but there's hundreds of ways that you can do them. Sometimes we find out that kind of the cheap, less efficient ways, if you do them in a smart way, are fine. So a lot of times it's just trying to keep things very simple and easy to control. And then something that's new that we started looking at when we did our first building and then really got into it in a deep way on the Packard Foundation. This is an example of where these really kind of stellar projects help to break new ground is the first time ever I got paid to do what we call plug load study was for the Packard Foundation. And this is the results of that study. So we helped them look at their plug-in equipment. And the idea was that if they didn't reduce that energy use in their plug-in equipment, we had to buy photovoltaics to offset that. And that was back when it was more like, instead of $2.50 a watt, it was like $9 a watt. So it was like hundreds of thousands of dollars if we couldn't reduce the energy use of their plug-in equipment. So we did this study, managed to come up with recommendations on just buying more efficient equipment and things like that, that would reduce the plug load use over 50%. And we've done that with Google and Microsoft and a lot of companies. And if you're smart about it, there's quite a bit of energy savings that you can use, or that you can capture. And residences are some of the same things. You'd be amazed at how much I could. I actually, in the old days when they were using, what were those things called, TiVo? One of my engineers took a meter home and put it on his TiVo, and it was like using like 110 watts 24 hours a day, right? And a couple years ago, I took my DVR, same thing. So they're more efficient. It was down to like 30 watts or something. But when I turned it off, it was like 25 watts in the off position, right? So it was just like sucking energy anyway. And then the last thing is you then put renewables in to offset the energy use. Although renewables have come down so much in price that there's times and places that we're putting them in that used to be that you like minimized your energy use and then you bought renewables like photovoltaics. That's not always the case anymore. So there's some cases where we're finding it's just cheaper to like use the less efficient equipment and just put in more photovoltaics. So, in the old days, it was so expensive that it was like a no-brainer. You did all the energy efficiency measures first. Now, most of the time, that's still true, but not always. Oops, sorry, wrong way. And then once you kind of do that, it's just a matter of sizing your renewable energy system, which is kind of that blue line, to area under the curve match the energy use of the building. And that's how you net to zero. Right? So, and one thing that a lot of people do is called a power purchase agreement, where you go in and hire somebody to come out, put the PVs in, own them, maintain them, and sell you the energy. And nowadays you can, on a larger project, somebody will come in and do that for you, and you're buying the energy at the same price or less than you would get it from the utility company anyway, and the rates are locked in. Either they'll stay flat or they'll go up slightly, but you know exactly what they're going to be for the next 15 years. So the last thing I want to talk about is kind of some of the things that we're thinking about, and maybe you might want to be thinking about what's coming up in the future. So one of the big issues is carbon, right? And the whole issue with carbon is global warming, actually, right? So I wanted to show these slides. So this kind of just graphically explains how net zero energy works on a building. So this is actually a project that we're looking at, the predicted energy use for a building, right? And I got one of my guys that was running the photovoltaic calcs to do a calc to how much PV they would need to offset the energy use of the building. So this is what he came up with. So this is for a specific day, March 21st, the spring equinox. And that's how much he was calculating the PV system on that day would need to generate if we're going to offset a year's worth of energy to net zero. So when you add kind of that yellow, which is the PV generation, to that blue, which is what the building uses, you get this profile that looks like that, right? That green. So at night, you're using energy, and then in the morning, as the PV starts kicking in, you start pushing the energy back onto the grid, which is what net zero is, and net metering is you're pushing the excess back onto the grid.
So can you stop just for 1 second?
Sure.
Because we're all thinking it. We know that this doesn't work anymore.
That's right. So that's what I was getting to. Okay. So that's that, right? That spins the meter backwards, right? So this is the utility. This is what I was getting to. So this is actual data I pulled off the net the other day for April 3rd. I was just working on the presentation on April 3rd. So that's kind of what the grid was seeing in California. But some days, if it's a really sunny day, you get additional renewables or photovoltaics, and you get that happening, right? And theoretically, you can get that happening, right? So in a building, if that happens, it's net metering, you push it back onto the grid, right? In the grid, if that happens, that's the duck curve, right? Everybody's heard of the duck curve, right? So if that happens, in theory, you can crash the grid, right? So so you guys know that this happened, right? Like, there actually were days that we were paying, that California had to pay Arizona to take excess energy because we couldn't use it, and you can't just like make it go away. So this is a problem now in California. It's a problem in Hawaii. It's a problem, believe it or not, in Washington because of hydro, not because of, so they have the problem this spring when the snow's melting. So the way California solves it is they're paying Arizona to take the energy. I don't know how much they paid, but it was negative pricing, so they actually had to pay Arizona to take excess energy. In Hawaii, what they've been doing is if you put a big installation in, they have the right to shut you off if they can't use the power. So that's another way you can do it. The other way that everybody's starting to play around with, and I'm sure you guys are thinking about this, is looking at putting battery storage in and then shifting that energy use into the evening. So I think that's the big thing that is being discussed a lot. A lot of our clients are now asking about battery storage. Tesla told me that the biggest market by far for Tesla Powerwalls, the residential scale ones, is in Hawaii because everybody's pissed off that they have to turn their PV off. And so they, instead of turning it off, they're putting in batteries so they could store the energy so they don't throw it away. There's this has anybody heard of this program, What Time? So there's this really interesting piece of software that was developed. The company, What Time, is actually in Oakland, but they developed this software with Microsoft and RMI, Rocky Mountain Institute. And what it's meant to do is track real-time carbon on the grid. And so Microsoft's playing around with it, trying to use it to actually, instead of being, we talk about zero energy, but it's actually net zero energy, right? So at night we're pulling from the grid, during the day we're pushing off the grid. This is actually to allow you to see if you're true zero carbon, right? So on a 5-minute basis, they're tracking the carbon content of electricity on the grid. And then what they can do is provide signals to buildings to then adjust their energy usage based on how much carbon's on the grid if you want to do that. So that's something really interesting that we're actually talking to some of the high-tech companies about, because they actually have requirements in place and goals to be true zero carbon. Right? Batteries are coming down in price, which is a huge thing. And battery installations are going up rapidly. Utility companies are putting them. Don was saying that you're involved in some purchasing power that's got storage attached to it. I know PG&E is working on it also. But one of the other things to think about is energy storage comes in many different forms, so you don't it's not just batteries that could possibly help solve this problem, right? So especially in buildings, you know, a lot of those projects that we did in Sunnyvale, we're using thermal mass to reduce the energy use. So what they're doing is at night, they open up the skylights, crack open the windows a little bit, and cool air flows in, cools down the mass of the building. They insulated the outside of the building, so once that mass is cooled down, then when people come in the next day, the building stays cool. So a month after they moved in, the temperature went up to 93 degrees for a week, even though it was like October or something like that. The air conditioner never went on, right? So if you design a building well and kind of use some of these things like thermal mass, we're doing another project where we're looking at in the summer, this sounds crazy, but using like thermal hot water and piping it into the ground. Not dumping the water into the ground, but putting like loops of pipes in the ground. So what you end up doing is making the ground hot. And you do that all summer long, and then in the winter you use a ground source heat pump to pull the heat out of the ground and use it for either heating buildings or heating swimming pools, things like that. So the ground could be a battery, right? A car can be used as a battery. Somebody told me that I think it's Nissan has got a system that they're selling in Japan but not here, where you can use your car as a backup battery for your house. You know, concrete can be a battery. Like India, we're using the concrete floor as a battery. There's materials now called PCMs, phase change materials, that take advantage of like the heat of liquefaction and solidification, like ice, that things change state and absorb or release a lot of energy without changing temperature. You know, water, we're doing a huge project with Microsoft, and they've got water storage tanks that they're using to dump heat into or pull heat out of. Hydrogen, right? I came here, I have a fuel cell car that uses hydrogen, so that stores energy. So a lot of different things you can do to store energy. So don't think of it as just, you know, lithium-ion batteries is the only answer, especially for buildings. And then, you know, we're starting to see, if you're going to put batteries in, then the obvious thing to do is do something called a microgrid, where you tie your battery and your photovoltaics together, and you could, if the power goes out, you could actually run your building even though the rest of the grid's out. So something like that. And we're doing at least, 4 or 5 projects right now? 6 projects that we're looking at microgrids, including the Atherton Civic Center project. One other thing I think that you really need to be thinking about, that hopefully you are thinking about, is the grid, or I'm sorry, you know, there's this huge increase in the number of electrical EVs. And so this is just statistics on where energy is used in the United States, right? But you can see transportation is a huge chunk of energy. So if all that goes electric also, that's going to have impact on the grid, and that's going to have impact on our buildings, because that's where they're getting their power from. It's coming into the building and then going out to the car. So I just checked a project that one of our other offices designed in Seattle for a high-rise residential. It was assuming that there were going to be a future 800 car charging stations, and it was a 2,000 amp 480 volt service just for that they had to leave space for. That was like half again as much as the energy use of the entire, you know, high-rise residential project. So it's a huge amount of potential energy that could possibly end up hitting our grid. And you know, the estimates for how quickly EVs are rolling out are changing radically. So this graph shows kind of the 2015 forecast, and then in 2016 they changed the forecast to increase the numbers 500%. So things are happening faster than they originally anticipated. And you know, this is a calculation one of my team members did to kind of estimate how much PV you would need to charge a car. So for, he was assuming you could charge 3 cars a day. This is like at an office park. You would need about a 3.5 kW PV system just to supply 1 car charging station. And then the last thing is autonomous vehicles. So, yeah, you could say that autonomous vehicles are going to use the same amount of energy. It doesn't matter if there's somebody in them or not, or somebody driving them or not. But the thing that I didn't realize is that what's anticipated is as autonomous vehicles become more and more common, one of the net effects is that it's not such a big issue to live far from your work, because you're not wasting time just sitting there like with your hands on the steering wheel. You could be working or sleeping or watching a movie or doing whatever, and so it'll make it easier for people to live further away from their offices or their places of work. And so there'll actually potentially be a lot more vehicle miles traveled and a lot more energy used by autonomous vehicles. And then the last thing that we're seeing a lot of that I'm sure you're seeing, actually, who is from Milpitas? You were, right? So Milpitas is sorry, Fremont is a, sorry.
That's a real slap.
Sorry.
Oh,
So
Bath County.
Fremont has been doing some really interesting things at the city level, looking at kind of smart cities. I don't know if any of the cities in Santa Clara are looking at that, but kind of data collection and use in cities. So this kind of smart buildings and smart cities is becoming an interesting phenomenon, and it's really, really early days, so it's hard for me to say, oh, this is going to happen and that's going to happen, but just the amount of buzz and the amount of change I've seen in the last 6 or 8 months is pretty amazing, and there's a lot of things happening, and a lot of it's coming from the Bay Area, because a lot of the innovation's coming from the high-tech industry. So the 2 places that I expect to see a lot of the technology coming from is here, Silicon Valley, and then Detroit. Mm-hmm. And the reason Detroit is because all the AI that's going into autonomous vehicles, in a couple years, people aren't going to think of vehicles as like, these cool cars that I have to drive around. Sorry. Vehicles are essentially going to be offices or places to hang out that happen to get you from one place to another, because you're not driving, so it's going to be more of a room for you to do stuff in while you're traveling. And so I think a lot of the technology that will be kind of introduced for vehicles will work their way into buildings. So I believe that's, and then Don was saying something about what kind of things can cities do, and Silicon Valley Clean Energy do. So this is a couple of things that I threw down, but maybe this is where we could have a discussion of what are the issues and what are next steps for the city, for the building industry, and for the utility companies. Questions?
I got to ask about hot water. So you're very PV focused. Is it just that PV's gotten so efficient now that you don't do direct hot water heating?
What we tend to do now is, because the solar hot water is so inefficient in the winter when you really need it. When you need the hot water, the solar panels are inefficient. But a PV system coupled with an efficient heat pump to make hot water is extremely efficient all year round. So, you know, it's a better, if you're going to do the PV, which has come down in price significantly, the heat pumps come down in price significantly, we find it's a better bargain almost every time to do the heat pump and the PV, almost every time. Now, a pool, like if you're heating a pool, and you don't have to have it, you know, super hot, sometimes it's better to do the solar thermal.
Yeah, Northern Europe, we see a lot of the evacuated tube hot
Yeah.
water heating. I don't actually see that much in the US at all.
They're expensive, they're complicated, you have to make sure they are evacuated if it gets too cold outside. There's some complexity to that.
Yeah.
There's not much complexity to PV, which is a benign thing that just sits on the roof or on a shading structure, and a heat pump that's running, it's just a compressor running. So,
One of the other things with solar hot water is I have that in my house.
Right.
Thanks, John.
Evacuated tube and all?
Not evacuated too. I have a Heliodyne. It's just a flat panel, black. But one of the issues is it's making tons of hot water in the summer when all I need it for is domestic hot water. And then it's making much, much less hot water and lower temperature in the winter when if I wanted to use it for heating my home, you know, it's not enough heat. Too much heat in the summer and not enough heat in the winter. So there's a mismatch between kind of when it's generating the most and when you need it the most. Yeah. So to be quite honest, I put in a size that's way too big so I can get a decent amount in the winter. And then I'm like, what am I going to do with it in the summer? So we're trying to figure out how to dump it into the pool, which, you know, and then the kids are complaining the pool's too hot.
You have to dump
On and on and on, right? So,
You only dump it in the spa. You can't.
yeah. I don't have a spa.
You need a spa, that's
So
what
I guess that's why I screwed up. So, any other questions? Yeah, Rod?
So, I've heard of some folks putting in ductless mini-split heating cooling systems. So in the wintertime, they can heat. So that basically, there's copper tubing going between an appliance, maybe up at the, you know, near the ceiling, and then copper going to an outside unit. So basically, in the winter, they're heating, and in the summer, they're cooling. Can you tell us anything about that and how you know, if we're an agency that has money to go help move people toward electric and fuel switch, do you think this is a valuable thing? And how would you compare the value that it brings versus hot water?
you know, it's definitely something we do a lot of because it is an easy, pretty cost-effective way to do all electric heating and cooling. You know, it's I live in Half Moon Bay, so I don't have a cooling system, but if your house has a heat pump outside and an air handler inside, it's no different than that. That's exactly what the system is. It just happens to be that the unit outside can serve a bunch of units inside, and there's just more piping between the two.
I think I can buy one on Amazon for $800.
Yeah. I mean, it's there are some, you know, there's always good and bad with everything, and it's always, you know, there's no silver bullet here. One of the problems with those systems is the refrigerant leakage, and they don't use a very earth-friendly refrigerant, so the global warming potential of the refrigerant in those systems is pretty bad. So they're working to try to rectify that, but when you're looking at total carbon and greenhouse gases, there are some issues there. But for now, to help folks get to all electric buildings and to get to true zero energy, we specify those systems a lot.
But would our investment and incentives be better placed in, I think you have an air-type heat pump. Water. Yeah. So would our investments be better placed there, do you think, or in heating?
You know, it's
Oh, you do. Okay. No, I hear you. I mean, okay. So let's.
I hesitate.
You know, every X years, we think about replacing our furnaces because the new ones are getting more efficient, right? So there's that, and then there's every few years the hot water heater bursts and we go replace it. So
Yeah.
I'm just wondering, you know, if you have thoughts on, for retrofits in particular.
You know, I hesitate to give you a blanket statement because, but we do use them a lot. One of the problems right now, or makes them cost effective right now is that, like what David has, and we do this a lot in buildings if the budget allows, is it's air on one side and water. So it's hot water or cold water. That requires insulated steel piping and pipe fitters that are very expensive to have, especially in this construction climate we have right now. So we find that those systems are kind of becoming priced out of the market, and the ones you described, we call them VRF, variable refrigerant flow. Those systems are less expensive because it's copper pipe and a plumber could do it. You know, anybody could do it. Anybody can install the piping. So again, I don't like to make blanket statements about anything because it sort of all depends on your situation. But we think it's a pretty effective way, depending on the type of building.
And then one last question. So I think the CEC voted today to require solar on every new home come 2020, something like that. What impact do you think that'll have on improving our sustainability?
Well, the grid goes-
Solar is in photovoltaic solar, yeah?
Yeah, I think so. They're basically saying it's now going to be part of every building new home that gets
Are
built.
they including a battery or not?
That I don't know.
Well, so we're back to the duck curve, right? Potentially, right? You guys know about that, right? So, so one solution is, right? You saw that curve, right? So it's they're just starting to get to the point where they're dipping into the potentially negative range that would be detrimental to the grid, right? So really what you want to do is actually make more of that, but when you hit that point where you're going to hit zero, make somebody turn some of the renewables off. So instead of going down and dipping into that negative range, you go down and then you stop just before you get to the negative range and then go back up again. But if you're going to do that, then the people that are putting in those systems need to understand that's going to be the deal, because if you put a system in understanding that you're going to be able to sell back all the extra power and some that you can't, that's a little bit unfair, right? With the cost effectiveness of renewables, a certain amount of that might be acceptable to a company that's investing in in a PV field somewhere. So it's not necessarily we're to the point where we shouldn't be putting in any more renewables. I think it's just one of those things where the rules are going to have to change a little bit. Otherwise, you're going to bankrupt PG&E again, right? Because they'll be forced to buy right now they're buying the energy at retail rates, right? And then you're going to be forced to pay somebody else to use the energy that you just bought. That's ridiculous, right?
Thank you for the presentation. I thought it was great.
Thanks.
Has the definition of net zero energy buildings changed? Because it seems like I've read about buildings that were labeled net zero energy, but they excluded the gas or something like that.
There's a lot of different definitions, so yeah.
Is there one that's defined by the state?
Is the state using TDB?
California has their own special definition.
It's different than the federal government.
We have to change all our marketing materials for that one, because that's how California labels it. And that's what they're going to call this 2020 for the homes and 2030 for commercial buildings. It's a very complicated, as you might expect, a very complicated calculation to get there. It has a lot to do with, you can actually get there using gas. It might encourage you because of duct curve and other issues to use gas to get there. So it's a very complicated thing. That definition we don't really use yet until we push to. We're using the simpler definition, and I think there are too many definitions out there. But what we try to do is say, let's keep it simple. When you're trying to get building owners, whether it's a jurisdiction, a town, a county, or whatever, or you want to kind of keep it simple. The simpler you can keep it, the better. So we just try to say, look, we're going to try to get this all electric building for you with no cost add, a very efficient all electric building, and then the PV is going to offset all that energy annually. And that's the definition that we tend to go with because we don't want to scare people off with something that's so complicated they can't understand. They just go, well, we're just not going to do that because, you know, we can't understand it and we got to get this thing built. Because we hear that a lot, believe me.
Let's thank our speakers. So we will, let's see, go into board member announcements and direction on future agenda items. Are you asking for ideas of future topics? Or?
No, we have some, but we'd like to take some ideas from you. We are thinking EVs is one. So similar to what we're doing with our industrial customers, we can offer some additional, but if there's some ideas that come up now, we'll take those.
Any
If not,
thoughts?
we have a whole list.
Okay.
Yeah.
Are we, any other ideas?
I guess
Yeah,
I'll
Rob.
make a comment. Maybe it's not completely fair to say this now that our guests have left, but the idea of a zero net building, I think the average person sort of sounds like a really neat science project, and it's kind of good for new buildings, but if we really need to move the curve, we need to be looking at what are the things that will change people's behaviors quicker than just, you know, a new fancy building once in a while. Like we obviously need to do the load shifting. You know, the net zero building by itself isn't gonna work if they're not thinking about making sure they either have a battery so they can transfer their energy to the evening time, for example. If they just think of themselves as net zero because I generated a lot of solar during the day and I use somebody else's energy in the evening, that just makes the problem worse with the duck curve. So I think we need to be thinking about more the things that we can do, you know, on a broader scale. I'm thinking, you know, the time of use rates is got to be something we figure out how to do, because that will force people, well, it won't force them, they'll be very market motivated to make sure they charge their cars during the day, and be motivated to buy utilities at home, appliances at home that they can program to charge during the day, kinds of things. So I think we want to have somebody come in with more of those kinds of ideas.
Right.
I could keep going with it, but I mean, that's sort of the idea.
Okay.
Anyone else?
I love the focus on EVs. There's tons to talk about there and tons to educate. I don't know if it's too technical, but having a discussion about water heaters, everybody has to replace their water heaters every 10 years or so, and there are so many options now. It's mind-boggling. So that's one, and then the other one would be the micro splits or the heat pump space heaters, which is the other big category of electrification. That just an informational session about what's available now. The comment about the refrigerants that have high GHG values, there's some that are CO2 based now, I think, which solves that problem. And there's so much complexity in this area.
Right. Anyone else? No? All right. Then we will adjourn and we will take a dinner break, and then we will reconvene at 7 o'clock for our regular board meeting. Thank you. And thank you, any members of the public who came. Thank you for participating.